In this video, we are going to discuss about an important question and answers of important questions or expected questions or model questions from D and F block elements. Here I gave a question or answer both. Okay, now from this, according to that sample paper, from this D and F block elements, they are going to give one 5-mark question. These are the important or expected or model questions CBSE. First question, account the following. Account the following or give the reason type questions. Give the reason. Zinc, cadmium, mercury are not a transition elements because they have n-1 d 1 to 10, the n-1 d10 and ns2 configuration. So therefore, these are not a transition elements. Okay. Transition elements means they should have incomplete electronic configuration, but zinc, cadmium, mercury, they are having complete electronic configuration, so therefore they are not. They are D block but not a transition elements. Next, transition metals are form a colored complex compounds. Okay, now whenever they are asking why these complex compounds are colored, means because of DDD transition and unpaired electrons. Unpaired electrons and DDD transition. These D block elements are what? D block metals are showing color property in solid state. That means aqueous. Next, why zinc salts are white, copper salts are colored? Because of unpaired electrons and DDD transition. Unpaired electrons is present means they are undergoing DDD transition, then they are exhibiting that what and color property. Next, transition metals and their compounds are showing catalytic properties. Why? Because of involvement of n-1 d and ns electrons in the bond formation. Okay, now like this, why manganese shows +7 oxidation state with oxygen, but with fluorine it will shows +4 oxidation state. Because manganese with oxygen it will make double bonds. With the fluorine it will make what? Single bonds. So therefore, in oxides are what? It will exhibiting that what? +7 oxidation state. Manganese can form p pi d pi bonds with oxygen, that is double bonds, whereas with the fluorine it can't make p pi d pi bonds. Next, this is very important question. Copper 1 is not known in the aqueous solution. Otherwise, copper +1 ions are unstable in the aqueous solution. Why? They will ask that question. Okay. Next, transition metals are generally exhibiting that what? Paramagnetic behavior because of unpaired electrons. Next, enthalpy of atomization of for zinc is what? Lowest. Zinc is lowest to Y. They are asking. And highest is for what? Chromium. Sorry. Highest is what? For chromium. Why? They will ask. Enthalpy of atomization means it is depends upon that what? And metallic bonding. More is the unpaired electrons, more is the metallic bonding. Sorry. Next, zinc, cadmium are soft metals. Soft metals means it is also depends on the metallic bonding. More is the number of unpaired electrons, more is the interaction, and more is the metallic bonding. Then more is the melting points and boiling points. And they are acting as a what? Hard in nature because of metallic bonding. Those metals are having that what? Hard in nature if they are having unpaired electrons. If there is no unpaired electrons, then there is no interactions, then metallic bonding is weak, so therefore they will act as a what? Soft metals. Zinc, cadmium, mercury, 0 unpaired electrons are present, so therefore no interaction, then metallic bonding is what? Weak, so therefore they are exhibiting low melting and boiling points, as well as they are showing that what? Soft character. Next one is transition metals are hard and have high melting points and boiling points. Already we discussed, no, because of unpaired electrons. Because of an unpaired electrons. See now. Next, which metal in the first transitions series exhibit a +1 and +7 oxidation state? Okay, now +1 is exhibiting by what? Copper. +7 is exhibiting by manganese. And one more question about manganese also is important. Which metal in the D block will exhibit maximum number of oxidation states? Maximum number of oxidation states are exhibiting by manganese. Maximum number, not highest oxidation state. Maximum number of oxidation states. +1, +2, +3, +4, 5, 6, +6, +7. These mean oxidation numbers it is exhibiting. Maximum number of oxidation state manganese will exhibit. Okay, next write the two characteristics of transition elements. Okay, next, by using these tips we can solve this what questions. See now, most of the questions of this D block elements, they are depends upon that what unpaired electrons. Now previously we saw that what questions, everything there depends upon number of unpaired electrons. More is the unpaired electrons, hard in nature, more metallic bonding, more melting point and boiling point. SR enthalpy of atomization is more, paramagnetic is more, and because of the presence of unpaired electrons, they are exhibiting that what color property. Because of the presence of more number of unpaired electrons, they are having that what paramagnetic behavior, and its magnetic moment is also very high. Okay, now like this. Okay, now this is number of unpaired electrons is depends upon this. More is the unpaired electrons, more is the metallic bonding, more is the melting point and boiling point, more is the enthalpy of atomization. Okay, more magnetic moment, that is mu. Mu is equal to √n into n plus 2. No? So more is the unpaired electrons, more is the magnetic moment. Next, for suppose if the compound does not containing no unpaired electrons, this is number of unpaired electrons. This is no unpaired electrons. No unpaired electrons means metallic bonding is weak, so they are acting as soft metals. No unpaired electrons means their magnetic behavior is diamagnetic, because they will not attract an external magnetic field. Because of the pairing of electrons, the total spin will become 0. Whenever the total spin becomes 0, it can't attract an external magnetic field, so therefore they are exhibiting diamagnetic. No unpaired electrons means there is no DDD transition, so almost they are colorless, that is white in color. Next, no unpaired electrons, metallic bonding is weak, soft in character, zinc, cadmium, mercury. Why they are soft metals means because of no unpaired electrons. And no unpaired electrons means their melting points or boiling points is low. No unpaired electrons means their enthalpy of atomization is also low. Okay, now these are the tips. Based on these tips we can answer the questions. Okay, most of these questions are depends upon number of unpaired electrons or no unpaired electrons. Okay, next questions. See now this question. Manganese is more stable than Fe2 plus towards that oxidation state +3. Here this model question is also important. Which one is acting as oxidizing agent or reducing agent? Mostly you have to see that their electronic configuration. If the elements or the ions which are having half-filled electronic configuration, full-filled electronic configuration, they are more stable. No? So therefore to get half-filled electronic configuration or full-filled electronic configuration, they may undergo oxidation or reduction. Okay, now see now manganese +2 state, D5 configuration, half-filled, more stable, cannot undergo further oxidation because it is +2 state, it is having D5 configuration. Already it is half-filled, so can't undergo further oxidation. Fe2 plus D6 configuration unstable. So therefore, to get D5 configuration, it can undergo that what reduction. Same, Cr plus 2 is reducing agent, Mn plus 3 is oxidizing agent when both are having the D4 configuration. So chromium plus 2 in aqueous state, chromium in aqueous state plus 3 state is more stable because T2G is half filled, more stable. Okay, that is. Otherwise you can write reduction potential of Mn plus 2 couple is what much more positive than this one. So therefore it is acting as oxidizing agent, it is acting as a what reducing agent. Lower oxidation state of transition metal is basic, higher oxidation state they may be amphoteric or acidic nature. Why transition metals are formed? Larger number of complex compounds, alloys and interstitial compounds. They are forming alloys due to their less size difference. When we are taking that what D block, for example, formation of the brass, for formation of the bronze, metal size difference is what very less between copper and zinc, almost less variation in their atomic radii. So therefore one atom can be substituted by another atom, so therefore they will form as a what alloys. Size difference is very less, so one metal can be substituted by other metal is easily, so therefore the D block elements they are forming that what alloys are very easy. Next, formation of interstitial compounds. Next one is, this is guarantee question. Complete the following equation. Complete the following equation. MnO4 minus, that is, this is all these reactions are related to KMnO4 reactions. All these reactions are related to potassium dichromate reactions. KMnO4 in acidic medium, nitrite is converting into nitrate. MnO4 minus 2 in acidic medium, it is converting into MnO4. Permanganate is converting into manganate, manganate is converting into permanganate. Next, permanganate ion in acidic medium gaining the electrons, converting into Mn plus 2. Okay, now it is converting sulfides to sulfur, thiosulfate to this, oxalate to carbon dioxide, oxalate to carbon dioxide. Next, KMnO4 on heating, it will give permanganate is converting into what manganate, Mn2O3 plus releasing of that what oxygen, MnO2. Next, dichromate reactions, potassium dichromate, acidic medium. Okay, now this is neutral medium. KMnO4 neutral medium, acidic medium, basic medium reactions you practice. Next, K2Cr2O7. Okay, no? H2S2 sulfur, stannous to tannic, iodide to iodine, ferrous to ferric. Okay, no? Now K2Cr2O7 in the presence of basic medium, dichromate is converting into chromate in basic medium. In acidic medium, the chromate is converting into dichromate. Okay, na? Basic medium, the dichromate is converting into chromate. Next, in acidic medium, chromate is converting into dichromate. Okay, ferrous is converting into ferric. And also once you practice that what KMnO4 structures, as well as K2Cr2O7 structures. That is very, very important questions. Structures. Next, describe the preparation of KMnO4 from the perlite ore. What happens when acidified KMnO4 solution reacting with ferrous? KMnO4 reacting with ferrous in the presence of acidic medium. Acidified means KMnO4 taken in acidic medium. KMnO4 in acidic medium. Ferrous is converting into ferric. And Mn plus 7 is converting into Mn plus 2. Write the balanced equation. Okay. This is from D and F block elements. So to learn this chapter or to answer this chapter quickly, first you should learn the at least scandium to zinc electronic configuration, number of unpaired electrons, magnetic moment. If we calculated, if we know the electronic configuration, then we can find easily number of unpaired electrons. If we know the number of unpaired electrons, it is diamagnetic or paramagnetic, color or colorless, more enthalpy of atomization, less enthalpy of atomization. Everything mostly depends on number of unpaired electrons. So therefore, that unpaired electrons we can calculate it by using only the electronic configuration. So therefore, you should practice scandium to zinc electronic configuration first, then count the number of unpaired electrons. Then you can start this solving the questions or answering the questions. Next, from lanthanides, mostly these are the expected questions. What is a lanthanide contraction and what is its consequences? Decrease in the atomic radii from lanthanum to cerium is called as lanthanide contraction. Consequences. Next, account the following. Zinc hafnium is having almost same atomic radii due to lanthanide contraction. There is a gradual decrease in the size of atoms. Why? Due to lanthanide contraction. That. Next, name the member of lanthanide series which is well known to exhibit +2, +4 oxidation state. Answer. Next, name the important alloy which contains some of the lanthanide metals and mention its uses. That is called as Mischke metal and its composition. Why actinide shows irregularities in their electronic configuration? Because of electronic configurations, extra stability of F0, F7, F14 configurations. Actinoids are exhibiting greater number of oxidation states than the lanthanides, because N-1d, that is N-1d, N-2f orbitals, energy difference is very less. So therefore, along with 7s, 6d, 5f electrons also participate, because energy gap is very less between 6d and 4f. So 4f electrons also participate in the bond formation. So therefore, they will exhibit more number of oxidation states when compared to lanthanoids. But in the case of lanthanoids, the energy gap between 4f and 5d is considerable. So therefore, 4f orbitals are not participating in bond formation. So therefore, lanthanides are exhibiting +2, +3, +4 only, not exhibiting more number of oxidation states, because 4f is not participating in the bond formation, that is 4f electrons, because of energy gap is more between 4f and 5d. Here energy gap is less, so participate. Here energy gap is more between 5d and 4f, so 4f electrons are not participating. Next, differences between the lanthanides with respect to electronic configuration, with respect to oxidation state. Okay, now we can write on the similarities between the lanthanides and actinides. These are the important or expected questions from D and F block elements. Thank you. For more important or expected questions in the biomolecules, you can watch the channel.